Hello everyone, welcome to RoshChem summary videos. In this video, I'm going through some calculations involved in energy from food. Okay, we'll look at this question. A bomb calorimeter was used in an experiment to determine the energy content of a biscuit. Initially, a constant current of 2.5 amps was passed through the electric heater for 70 seconds at a potential difference of 6.85 volt. The temperature of 200 ml water increased from 18.25 degrees to 18.38 degrees. Okay, part A. Calculate the calibration factor of the calorimeter in joules per degrees. Okay, so how do we find the CF value? No, we know that CF equals to energy over delta T. Energy, this is electrical calibration, so I can say energy equals to VIT over delta T. So V is the voltage, which is given 6.85, and I is the current in amps, so which is given 2.5, and T is the time, should be in seconds, so it's already given in seconds, so it's 70 seconds, and delta T is the change in temperature. The two temperatures are given, so you can find the change. So then you get this answer 9.22 10 to the power 3, right? What's the unit, right? Energy here, energy can be joules or kilojoules, because I'm using VIT, I get joules here. Then you joules, you divide by degrees, so that's why it's joules per degree. So now for this calorimeter, the calibration factor is in joules per degree. So it's this is the answer in joules per degrees. Okay, now we will look at the next question. Okay, now it says a 2.25 gram sample of the biscuit was then burnt in the same bomb calorimeter. So same bomb calorimeter means the same, you can use the same calibration factor to increase the temperature of water from 16.32 to 24.85. Okay, calculate the energy released by the combustion of the biscuit in kilojoules. Okay, so I know that CF equals to energy over delta T. Therefore, energy equals to what? Energy equals to CF times delta T. That's what I have done here. Energy equals to CF, because it's asking in kilojoules. In my previous question, I had my CF in joules per degrees. So to make it to kilojoules per degrees, I divide by 1000. So then I get 9.22 times by the delta T. This is the change in temperature when you burn those biscuits, right? That's the temperature change. These are the two temperatures when you burn those biscuits in the calorimeter. So then CF times delta T. So you get 78.7 kilojoules. Okay, then calculate the energy content of the biscuit in kilojoules per gram. So this much of energy I get for how many grams? 2.25 grams of the biscuit. Therefore, if I want to find how much of energy I get for 1 gram, so this answer here, I divide by 2.25. Then I get 35 kilojoules per gram. So this is how you find the energy content using the CF value. Okay, so look at this question. Explain why the above calorimeter was calibrated before doing the combustion. So why we have to calibrate the calibrate a bomb calorimeter. So when a reaction takes place in a calorimeter, the heat change can increase or decrease the temperature of the content of the calorimeter, and this can lead to inaccurate results. Therefore, to obtain more accurate results, we have to first find the calibration factor of the calorimeter. This is known as calibrating the calorimeter. So that's why we have to calibrate the calorimeter. Okay, what would be the effect on the value of the calibration factor calculated if 100 ml of water had been used in the calorimeter rather than 200 ml? Okay, so now we know that CF equals to energy over delta T. Okay, so now they are using 100 ml of water rather than 200. If I use 100 ml of water, which means less water, what will happen to the delta T? The delta T will be higher. That value will increase. So if the delta T is higher, what will happen to CF? It will go down because you divide by a bigger value. So CF value will decrease. So that's why the CF will be lower. Okay, so this is another type of question. The student used a mixture of 0.15 grams of cashew nuts and an unknown mass of walnuts to heat 2.5 liters of water from 40 to boiling point. Okay. In another experiment, the student found that the energy content of cashew nuts and walnuts to be 28.2 kilojoules per gram. That's for cashew nuts, and for walnut, it's 16. Okay. The student is burning a mixture of cashew nuts and unknown mass of walnuts to heat water, right? So part A, calculate the heat energy absorbed by water to increase its temperature to the boiling point. For that, I can use Q equals to MC delta T. Okay, so what is the mass of water? 2.5 liters. So how do I convert 2.5 liters into the mass? 2.5 liters means 2,500 ml, right? To convert into mass, I multiplied by the density. So that's why I have used the density here. So 0.997 is the density. You times by how many mLs you have. So then you get your mass in grams. Okay, then 4.18 is the C value that's in your data book, the specific heat capacity of water. And change in temperature, water is at 40, it's going to boiling point, which is 100. So the change in temperature is 60 degrees. So I get this answer then. So because I'm using grams for the mass, right, energy will be in joules. So then I divide by 1000 to make it kilojoules. So this is the energy absorbed by water. Okay, what is the energy released by 0.15 grams of cashew nuts? Now, for cashew nuts, what we know, it says the energy content is 28.2 kilojoules per gram. And also I know how many grams I used, right? So therefore, so 1 gram is releasing 28.2 kilojoules because I use 0.15 grams. So then how much of energy released? You multiply those two values together. So then I get 4.2 kilojoules from cashew nut. Okay, next question, it's asking what is the mass of walnuts used in this experiment? Okay, so now we know, so both, you are burning both cashew nuts and walnuts, they both are releasing energy. This energy was given to water to heat water. So I know how much of energy absorbed by water. The energy absorbed by water is 6.3 times into the power 2. So that came from where? Burning the energy, it came from both cashew nuts and the walnuts. Okay, now I found how much of energy released by cashew nut. Therefore, the difference is the energy released by the walnut. So this is what I did here then. Energy by walnuts, this is the energy absorbed by water. So I use the original answer before you round off. So I use that answer here, but I made it kilojoules because this value in kilojoules, right? Then minus the energy released by just the cashew nut. So then therefore this is the energy released by the walnuts. So this, right? So this much of energy released by an unknown mass of walnuts. Now it's asking what is the mass of walnuts used. So I have this value. I get 16 kilojoules from 1 gram of walnut. If I have 1 gram, I get 16 kilojoules. So now I have this much of energy. Therefore, to get this energy, how many grams must be there? So it's 620 divided by 16. So therefore, there must be 39 grams of walnuts to give this energy. Okay, so that's the end of this video. So please practice questions from RoshChem 3 and 4 study guide. The questions are on pages 150 to 156. And thanks for watching my video. If you need any further information, please visit our website, www.roshchem.com. Thank you. I'll see you in another video.